Adding and subtracting polynomials. So in this section, we are going to be looking at some polynomials and adding and subtracting them. There are these two definitions that you need to write down based on adding and subtracting polynomials. For the first one, you need to write polynomials can be added in either vertical or horizontal form. In vertical form, align the like terms and add. In horizontal form, you're going to use the associative and commutative properties to regroup and combine like terms. You'll also be subtracting polynomials. For the second bullet point, when you're subtracting polynomials, remember that subtracting is the same as adding the opposite, and you're going to find that helpful by adding the opposite when you're subtracting polynomials. To find the opposite of a polynomial, you must write the opposite of each term in the polynomial. So let's do a few examples of this so this makes sense when you have this for bookwork. It says here add or subtract. So we have 2s squared plus 3s squared plus s. The first thing we need to do is identify our like terms. Our like terms are going to be the s squared because they both have an s squared. The s standing alone is not like the others because it doesn't have an s squared. So I put in red here 2s squared plus 3s are my like terms, then plus s stands alone. And then what we're going to do is combine that. 2s plus 3s is going to give me 5s squared plus s, which we did is combine like terms, and this 5s squared plus s is going to be my final answer. For b, I have 4z to the fourth minus 8 plus 16z to the fourth plus 2. So the first thing, we're going to identify like terms. We have our 4z to the fourth, 16z to the fourth are like terms. And then we do have constants, numbers that stand alone are -8 and are plus 2. So in the red is going to be the z raised to the fourth, 4z to the fourth, 16z to the fourth. The blue is the constant values. So now we're going to combine like terms. 4z and 16z is going to give me, actually before we can combine this, it would be good to rearrange the terms so that they are like together. So notice how we put the z's to the fourth in front and the constants behind. So it just says rearrange the terms so that like terms are together. Here we can combine them. 4z, 16z is 20z to the fourth, and -8 plus 2 is going to give me -6. So my final answer for this is 20z to the fourth minus 6. Make sure too, when you're writing out your notes, you're doing each of these steps and labeling each step so that you understand the process. Here we go, we're adding or subtracting these like terms. So we have 2x to the 8th plus 7y to the 8th minus x to the 8th and minus y to the 8th. Sorry about that interruption. Where I left off though is I was explaining that you have all exponents of 8, but you have different variables. So you have x to the 8th, but then you also have y to the 8th. So your like terms here are going to be 2x to the 8th, negative x to the 8th, and then your other set of like terms are going to be 7y to the 8th, negative y to the 8th. So let's first find our like terms, which we did. Notice the red is x to the 8th. So we have our 2x to the 8th, and our negative x to the 8th is in red. Our 7y to the 8th and negative y to the 8th is in blue. So we identified our like terms. The next thing we're going to do is rearrange our terms so that the like terms are together. So we have 2x to the 8th minus x plus 7y to the 8th minus y to the 8th. And then we'll just combine that. So 2 minus 1 is going to give me x to the 8th. 7 minus 1 is going to give me 6y to the 8th. So this x to the 8th plus 6y to the 8th is my final answer because we combined our like terms then at that point. The next one, D, we have 9b to the third power c squared plus 5b to the third c squared minus 13b to the third c squared. So let's combine like terms. Notice they all have b to the third c squared. So actually each of these are like terms, so notice they're all in red. We can leave that. And then we just simplify 9 plus 5 minus 13. That's just going to leave me left with 1. So that's how we just got b to the third c squared. Or you could have wrote it as 1b to the third c squared. It means the same answer. Let's look at this example here. It says add 5a cubed plus 3a squared minus 6a plus 12a squared plus 7a to the third power minus 10a. So the first thing we're going to do is find our like terms. So we have here in the red are my a to the third power. The blue color is a squared, those like terms. The green is just a standing alone. I'll put a triangle around that. Notice I kind of use different symbols as well to highlight like terms. So I first underlined a to the third, I circled a squared, and I put a triangle around just a by itself. So we found the like terms. Now we're going to put those like terms together. So I have 5a to the third plus 7a to the third plus 3a squared plus 12a squared plus a negative 10a minus 6a. So we'll combine that now to get 12a to the third, because 7 plus 5 is 12. 3 plus 12 is 15a squared. Negative 10 minus 6 is going to give me a negative 16a. So here is my final answer. Our last example here, example 3, we're subtracting now. So we have 2x squared minus 3x squared plus 1 minus x squared plus x plus 1. So what we're going to do first with subtracting polynomials is we're going to rewrite the subtraction as adding of the opposite. Remember, one of the first definitions said when you're subtracting is adding the opposite. Don't forget, when you add the opposite, you have to do it to each term inside the parentheses. So this minus becomes a positive. We have x squared, that becomes a minus x squared, plus x becomes a minus x, plus 1 becomes a minus 1. So think of the opposite there when you add the opposite. So then the next thing we're going to do is find our like terms. So we have our 2x squared minus 3x squared, and then that minus x squared. In the blue are like terms. Then the green, we have a plus 1 and a minus 1. Those are other like terms. So let's group this together. Now the way they're adding these here is they lined it up vertically. So notice how this plus 1 minus 1 cancels to become 0. A 0x minus an x just is a negative x. Negative x squared becomes negative 2x squared. So when we add this together, we get negative 2x squared minus x, and that will be my final answer there. And notice how the note said use the vertical method, write 0x as a placeholder for not having an x here in this first group of values.